Hello, friends. Today we're continuing our study of geometry. Now we're into the second quarter, right? If there are 120 lessons, then we're now at lesson 31. Today I'm actually going to do lessons 31 and 32. I want to go through 31 pretty quickly. It's just about two different kinds of proofs, and you don't see them very much. I don't even really see these much in other textbooks, but it's worth talking about because one of the forms is kind of the way that the math is usually done when it's presented in a journal type format. And then 32 will be more about triangles. You didn't know there was more, and yet there's even more after this. So let's get into it. Lesson 31, flowchart and paragraph proofs. So the way a flowchart proof works is it's pretty much the same as a two-column proof, except that the statements go in boxes, and then you put reasons kind of like below and next to the boxes. That's it, really. So here's a proof from lesson 27, if you want to go back and look at that. But the proof was this. Given this situation, these two parallel lines prove that angle 1, measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. This is a proof that the three angles of a triangle add up to 180 degrees. So we start with the given. So I just write the given information in this box. I mean, literally just taking what I would write in the two-column proof and putting it here. And then the given information, right? That's what that is. So then I move on. These would be the next two reasons, or statements, I should say, right? And then, so angle 4 is congruent to angle 1, angle 5 is congruent to angle 3. Two separate things, so I put them in two separate boxes. You could put them in one box. And how do I know that? I know that because alternate interior angles are congruent when I have parallel lines. So that would be the reason. Next statement, measure of angle 1 equals the measure of angle 4, measure of angle 5 equals the measure of angle 3. How do I know that? Because the definition of congruent angles, it means that they have the same angle measurements. By the angle addition postulate, I know that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is 180. Going back to the diagram, that's this, right? These three add up to 180 degrees, sort of a linear triplet, you could say. It's the angle addition postulate. And then by substitution, so substituting 1 for 4 and 3 for 5, I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180. Substitution property of equality, I'm substituting QED. That's it. And so if you're going the other way from a flowchart to a two paragraph or to a two column proof, what you would do is just take the things from the boxes, put them in the left-hand column, take the other things here, right, the reasons, and put them in the right-hand column. That's it. A paragraph proof is how proofs are done in mathematical, scientific journals, etc. It's basically a description. All you have to do, imagine that you're talking through this with someone. Well, we know that this angle is equal in measure to this angle because of what we know about parallel lines, and then you would just say it. So it's just taking the whole thing and writing it all out in full sentences. And everybody loves writing things in full sentences, don't they? I know. Calm down. It's going to be okay. But that's what a paragraph proof is. Okay. And I don't feel the need to give an example of it. Okay, let's move on to lesson 32, the median. Okay, so there are a whole bunch of types of lines that you're going to need to know about with respect to triangles. One of them is the median. Okay, and these different lines form different centers. And so where's the center of the triangle? It's like, which center are you talking about? Because I'm going to show you there are a few. Some of them are really strange because they don't even seem to be in the triangle, but it's part of the way that we define these things. So a median is a line segment that goes from a vertex to the midpoint of the opposite side, or from the midpoint of the opposite side to the vertex, right? So how do we know this is the midpoint? Because I've got these little congruent symbols. This side's congruent to this side. This is the midpoint. That's the vertex. This segment connecting them, that's the median. If I draw all three medians, then I get what's called the centroid. The centroid is the center of the triangle formed by the intersection of the three medians. And the three medians should all connect. In the end, you're going to have a bunch of these types of centers, types of these segments. So start to memorize them now. Median, vertex to midpoint. Centroid, formed by the medians. But there's also a theorem that goes with the centroid, and that's this, that the centroid is actually 2/3 of the way or 1/3 of the way across the median. So it's 1/3 of the way from the midpoint to the opposite vertex. So in other words, what I'm saying here is that AT, this segment, is 1/3 of the full length MT. I have that written here. Also, MA is 2/3 of the full length of MT. They're written here. And what that also means is that MA is twice the length of AT. So if you're given the length of AT, then you can find the length of MA and MT, etc. You're going to see problems like that where you've got to somehow you know that you have a centroid, you're given some length, and then you're going to find the other lengths. And this is the key to doing that. Okay. Median, midpoint to vertex, centroid formed by the medians. Okay, another type of segment is an altitude. It's a segment that is perpendicular to one side and it intersects with the opposite vertex. Okay, so there's something like this, triangle like this, that's easy, right? So I draw a line from the vertex to the opposite side and I make it so that it's congruent, or it's perpendicular, not congruent. Okay, but what about something like this? If you have a right triangle, then the median, or sorry, the altitude is just one of the sides. It's one of the legs of the right triangle. If you have an obtuse triangle like this, well, this gets interesting, right? Because what you have here is, how do you draw something that's perpendicular to this side and it goes to the vertex? So we extend the side and then we end up with this is the median, sorry, the altitude. This is the altitude right here. Now, if I draw all three altitudes, the place where they intersect is called the orthocenter. So it's a triangle center formed by the intersection of the altitudes. So this is the first triangle. This is the line I had before. So then if I draw a line from here and make it perpendicular to the opposite side, it goes that way. And then same thing, this segment is going through the vertex and is perpendicular to the opposite side. They all intersect at the orthocenter. If you have a right triangle, then the right angle, that vertex, that is the orthocenter because, this is uh, the altitude to this side. This is the altitude to this side. So now I just have to draw the altitude to the hypotenuse, and it uh, goes through this angle, goes through that vertex. If I have something like this obtuse triangle, then it gets a little bit weird. This is the altitude that I drew before. So now I'm actually going to draw this, I'm going to extend this. The altitude from this side, perpendicular here and going there, right, through the vertex. So I need to extend it because this doesn't intersect over here. So we extend the altitude and eventually it hits here. Then what about the one that's, perpendicular to this side? This is the one I'm missing. So again, I have to extend this side all the way out until I can get to a point that's perpendicular to this side and going through the vertex, this opposite vertex, right? This vertex is opposite to this side. Extend this altitude and it meets down here. The orthocenter is like, that's not even in the triangle. How is that a center? Well, it's a place where the where these segments intersect, right? Where these lines intersect, actually, in this case, because you have to extend them. So it's one of the ways that we talk about the centers of these triangles. So a little bit confusing, but remember, median, midpoint to vertex, and they form the centroid. Altitudes, perpendicular to each side and through the opposite vertex. And they together form the orthocenter. Ortho means right. If you think like orthodoxy, that means right teaching. Orthopedics, the right uh, right arrangement of the bones in the feet and all that kind of thing. So ortho meaning right angles. So you've got altitudes, they are at right angles to the sides. So the altitudes form the orthocenter. Thanks for watching. Don't forget to like and subscribe and share.